Okay, so we're doing limits at infinity and horizontal asymptotes. Um, what limits at infinity means is you're taking the limit as x approaches infinity or negative infinity. So if you look at this little graph here, if you took the limit as you went to infinity, doesn't that mean you would follow this graph to the right forever? Okay, if that happens, do you see how that graph is approaching this horizontal line here? So that's a horizontal asymptote, okay? Doesn't it approach that same horizontal line as I'm going out to the left for this particular graph? So that's the only horizontal asymptote of the graph that's there. So this is the graph we're talking about. The other way you can do it is you can look in the table. Looking in the table sometimes is difficult to do because you're looking at, oh, okay, if you go by ones or go by twos, it's hard maybe to know exactly what it's going to. If you go by hundreds or thousands or millions, pretty soon it'll just say 1. So then you know your horizontal asymptote's at 1. A lot of times you're not going to have your calculator for that type of question. But if you do have your calculator, your table actually gives you the answer because it's so close to 1 that it'll round it up to 1. Okay, so as x grows larger and larger, positive or negative, you can see the values of the function are getting closer and closer to 1. So you can say the limit as we approach infinity for this function is equal to 1. Okay, so questions on the concept of it? People always have these misconceptions about horizontal asymptotes. I hope I cleared them up with you guys last year. Vertical asymptotes you cannot touch, right? They're very aggressive. That's why they're VA. Vertical asymptotes, don't touch them because they're very aggressive. Horizontal asymptotes, I don't have anything clever to say about them. Not that very aggressive is clever. But horizontal asymptotes, you can cross them as many times as you want, okay? So like here, as we go out to the right, it's approaching, I think this is 1 here, but it's approaching whatever that value is as we go to the right. As we go to the left, it's approaching a different value. So how many horizontal asymptotes do I have in this first graph? I have 2. I have 1 up here, 1 down here, right? When I am going with a function that's oscillating and getting smaller and smaller, it's got that damping harmonic motion, I suppose, going on there. What value is this approaching? 0. So there is a horizontal asymptote at 0. Do you see how many times this function is crossing through 0? That's okay. All right, it's still a horizontal asymptote because of the definition says as we go to infinity, that's what the graph is approaching, or negative infinity. Okay, this one here, it's actually approaching 0 as we go to the right and approaching 0 as we go to the left. This one's just above and this one's below, and it crosses through. It's okay if it crosses through. Okay, so any questions on that? There's too many people that come into calculus thinking that it's an asymptote, you can't cross it, and then they don't identify those as asymptotes. That's not true with horizontal ones at all, okay? So questions on the concept, or are we good? All right. All right, I don't know if this is in your notes, is it, the picture? Okay. I put it up on here. I didn't have it in there like last year, and then I just finally threw it in there through a scanner. So find the infinite limits, limits at infinity, and asymptotes for the function f whose graph is shown. So go ahead and try to identify or find the infinite limit. So find the limit as x goes to infinity. So that's one of the things I want you to write down here. And I'll just use f of x. The other infinite limit would be as x approaches negative infinity. Okay, so that would be the infinite limits. Limits at infinity. Oh, sorry. That would be the limits at infinity. Infinite limits would be when the value is going up to infinity or down to negative infinity. So you have to identify where those spots are, okay? So you want to find the limit when the function is going to infinity or negative infinity. So find what x is approaching for those. Sometimes you have to approach it from one side and the other side because they're going to different values. and then find the asymptotes. So you should have some vertical asymptotes, and you should have some horizontal asymptotes. And write those as functions, obviously linear functions. I'll give you guys a minute to try those, and if you have a question, you can ask me or someone else here. Okay, what's the limit as we go to infinity look like it's going to? Based off of the graph there. Did you guys get 4? As we're going to infinity, it's going to 4. Okay, as we're going to negative infinity, it looks like it's going to 2. So what does that tell me? That tells you the horizontal asymptotes. I'm going to delete this and rewrite that. So horizontal asymptotes, what's the equation for a horizontal asymptote? Yeah, it's y equals 4 because it cuts through the y-axis at 4. And then this one would be y equals 2 because it cuts through that y-axis at 2. Okay, so just be careful that you don't mess that up when you did all the calculus, right? Okay, then the other part was where there's the infinite limits. So those are occurring at, what value is this, -1? And as you're approaching -1, isn't it going to the same infinity from both sides? So I don't have to do a right-hand limit and left-hand limit. So that's going to infinity. And if I do the limit as we approach 2, do you see how it's going to different infinities from each side? So really you should say I'm going to approach it from the left, and then I'm going to approach it from the right. That way I can have this mathematically accurate here. Being mathematically accurate is kind of important on the AP test. Okay, so as I approach from the left, it's going to which one? Negative infinity. As I'm approaching from the right, it's going to positive. So what does that tell me? Okay, but more specifically, what's the equation for a vertical one? X equals. There you go. So questions on that at all? Okay, I'm going to give you a couple minutes to try those bottom ones. The first one should be pretty quick if you remember how to do them, because it just is. The second one, if you remember the trick to it, it's really quick as well. So I'm just going to give you a minute. If you don't remember the trick, I'm just going to spoil it for you. So as we're approaching infinity, if we get 1 over infinity, it's going to 0, and the other one is also going to 0 as you go to negative infinity. It's getting humongous down there. It doesn't matter if it's positive or negative. Does anyone remember the trick to this one? The highest power, yeah. So what do you do with the highest power? Huh? Oh. Yeah, so it's x squared in the denominator and x squared in the numerator. So you don't even have to think about if it's the denominator or the numerator that you're trying to do the highest power of. Just divide everything by x squared. So divide all terms by x squared. So if I... Okay, go answer it. Okay, so what happens to these fractions that I'm getting? So what happens if I go to infinity with all of these fractions? They're all going to 0, which is the reason to do that, so we end up with an answer of 3/5. Okay, and being able to do limits is important when we get to that last chapter, the hardest chapter. So it's good that we're reviewing these limits before we get to that stuff. So any questions on that? Okay, well, that was my big graph. We're not going to do all of this one. I want you to try these ones here, and I'm going to give you, I don't know, 5-ish minutes, and then we'll spoil them for each other and get all the answers. All right, so the right side, what should this first one be? infinity, and this one should be negative infinity. So that one was easy. Don't know how Medford didn't get that one. Just kidding. Okay, now this one's easy, but you guys have it wrong. Okay, if you're taking the sine of x that's oscillating up and down between -1 and 1, as you go out to infinity, what is that approaching? Doesn't it just keep moving? It's not actually approaching a value, right? It's just going up and down. So that one would be does not exist. Yeah. This isn't the easy page. It's just the page that I expect you guys to be able to do. Okay, so you guys want to do the bottom one? What'd you divide by? Or I'm assuming that's what you did. Okay, so you divided everything by x squared. I thought that was a cubed. Yep, so x squared, that's good. So if we divide everything by x squared, we would get 1 plus 1 over x, and then 3 over x squared minus 1 over x. Does that look right? Okay, now what's the issue with what they did, Medford? Go ahead and correct them.
The degree of the numerator is not equal to the degree of the denominator.
That's true.
So it's wrong.
It is wrong. Okay, what would happen if you went to infinity? What happens to all these fractions? They go to 0, so what would you get? You get 0 on the bottom, so that doesn't work. And that's a very common mistake. People just look for the highest degree. You're actually looking for the highest degree in the denominator, okay? But the nice thing is if you mess it up, you can see you messed it up, and you can quickly fix it. So what am I actually going to divide everything by? X. So this would turn into x plus 1 over 3 over x minus 1. Does that look right? So then this goes to 0 here. So the denominator is just -1. And what happens in the numerator? Infinity. So here's a spot where you would write negative infinity. But on the AP test, instead of writing negative infinity, what would I want you to write? Does not exist. Because you might forget to pull that negative over, and then you don't get your points. So it does not exist, but in our notes we'll write negative infinity there, so I suppose I could have left that. So questions on that side? Okay. Okay, so now the left-hand side, who knows how to do the first one? Let me put it over 1. Now who knows how to do it? Alley Cat, you do, right? Conjugate. Okay, so you're going to multiply the top and bottom by the conjugate. Did anyone get that one? So I'm going to give you a moment to do that. I'm going to do it up here at the same time. But then you can just check your work. We get infinity in the denominator, so yeah, we should get 0 then. Does that make sense though? It's not a hard one. When you see that square root and then another term back there, a lot of times it just looks like that for conjugate. It just wasn't in the fraction forms for you to see it, okay? Okay, this next one we're approaching 0 from the left. It's kind of hard to see up there. What is happening to this as I approach 0 from the left? So I'm going to get 1 over, obviously, a small what? Positive or negative? Negative. So if I have 1 over a small negative, what's that going to go to? Negative infinity. So it's kind of like I have e to the negative infinity, right? This is just scratch work. I'm not writing anything equals this. Isn't e to the negative infinity the same as 1 over e to the infinity? So what does that go to? It goes to 0. Okay, and I always have someone who wants to do the last one here a certain way and get an answer that doesn't give you the right answer. Okay, if we just substitute infinity in, don't we get infinity minus infinity? Can you determine infinity minus infinity? Because one might be like 4 more than the other, right? So what can you do? I heard you say it. Take an x out. If you take an x out, you're left with x times x minus 1. And now if I plug in infinity, what do I get here? And if you're multiplying two things that are infinitely large, you're going to get infinity. So we would write. Yeah.
No, I'm not going to answer.
Okay, any questions? All right, there's your homework.